Welcome back for our final notes to review for our Problem Stats Final. Thank you so much for joining. Today we're going to cover 3 chapters actually. Chapter 6, 7, and Chapter 4. So let's start with Chapter 6. So this was the most recent thing we did, so hopefully this is the freshest in your minds. So Chapter 6 was all about normal density curves, all right? Now something that's true about any density curve is remember the area is always equal to 1. And that's actually why these turn out to be such good probability questions, because having an area of 1 just simplifies the process of considering these as probabilities. Something else that was in this chapter, which actually started in Chapter 5 for us, is also the idea of shape, and then what that shape does to the mean and the median. My hint for you here is remember the outliers, or in this case we can consider that the tail, that is what's pulling on the mean, okay? So here we call this first one skewed left because the tail is trailing off to the left, okay? And that tail is gonna pull on the mean much more than it pulls on the median. Now I'm gonna jump over here for a little bit. This one is skewed right. Again, because its tail is to the right. Again, that tail, those outliers, that is pulling on the mean, where the median is going to remain much less affected, closer to that peak. Finally, when they're the same, when it's just this nice symmetric curve, we call this symmetric. And for symmetric, when there is no tail, okay, there's nothing pulling on the mean, well, the mean and the median stay directly in the middle, in the center. So there is something you do want to make sure you remember for your final. And again, hopefully it's easy by this point because we did that in multiple chapters here. The first part of 5, the second part of 5, and in Chapter 6 that came up. Another thing, when we first started Chapter 6 is about percentile. Percentiles is a number with a certain percent of the data less than or equal to it. So if we're looking for the percentile of a score of 80, well, remember the first thing we need to do is count, well, how many things are less than or equal to it. So here I see 1, 2, 3, 4, 5, 6. There are 6 numbers less than or equal to the 80. But to turn that into a percentage, we have to divide it by the total. 7, 8, 9, 10, 11, 12, 13 numbers there. So 6 out of 13. That gives us 0.46, aka the 46th percentile. Okay, so percentiles are just the percent that are less than or equal to whatever you're looking at. Now, the next thing we talked about is z-score. And z-scores measure how many standard deviations above or below the mean you are, okay? A positive z-score means that you have a positive, or you are above average. A negative z-score means that you are below average. The formula for this is we take our observation, we subtract the mean, and then we divide by the standard deviation. So, as an example for that, here we have the class average on the last problem stats exam was 83 with a standard deviation of 3. What is a z-score of someone who scored an 89? Well, a z-score, you take your observation, so take that 89, minus the mean, which is 83, divide by the standard deviation, which is 3. So here, 6 divided by 3 equals 2. So this individual would have a z-score of 2. And again, based on the definition we just gave above, that z-score means that they are 2 standard deviations above average, 2 standard deviations above the mean. Now we can also do this in the reverse. I can give you a z-score and ask you what observation would be there. So we're using that same formula, but this time I know the z-score. What I don't know is that observation. But I still know the mean, and I still know the standard deviation. Okay, so here, again, you can use this formula in the reverse. I give a z-score, and I ask you what observation would have been sitting there. From here, this is just algebra. I need to multiply by that 3 to get rid of that. So this gives me -6 equals x minus 83. And now add 83 to both sides to get 77. Now, what you probably remember the majority of the chapter being is using the table, using table A. That was a huge component to this chapter, okay? So a couple things I need you to remember. And again, you probably notice I am talking very quickly as I'm going. If you need to pause to finish writing what I'm saying, that is a perk of these videos, okay? So I'm going to just fly through these. Again, pause as necessary so you can write everything and keep up with me. So if the prompt is less than, that is literally whatever the table gives you, okay? You look at your z-score in the table, and whatever it gives you, boom, that's your answer. Greater than, remember you have to take 1 minus whatever the table gives you, okay? You have to do the reverse because the table is built for less thans. For between, you have to look up both values in the table, then subtract them. And if you're given the percent and asked to find the z-score, that's where you work backwards. You find the percent in the middle of the table, work your way out to the z-score, okay? So just to really quickly model each of those for you, what percentage of observations are less than a z of 1.32? So remember, that's where you have to find a positive, or on the positive side, you need to go down to the 1.32, or sorry, down to the 1.3 and over to the 2. And then you find where those meet. So those meet at 0.9066. And because it's less than, we get to just leave it like that. That's it. Our next one, what percent of observations are greater than -0.42? So this time I need to go to the negative side. Again, this tells me to go down to the 0.4. This tells me to go over to the 2 and see where they meet. And here they meet at 0.3372. Now the catch is because it's a greater than circumstance, remember that means you need to take 1 minus what the table gives you. So 1 minus 0.3372 gives 0.6628 as your final answer. For the between ones, so between a z of -1.92 and 0.76, so let's start with that -1.92. So I'm going to go to the negative side. Z -1.92. Again, this tells me to go down to the -1.9. This tells me to go over to the 2. And that gives me 0.0274. So 0.0274. Oh, oops. Wrong one. 0.0274. Then find the 0.76, which will be on the positive side. This tells you to go down to the 0.7. This tells you to go over to the 6. And again, find where they meet. And here they meet at 0.7764. Oh, too far. So 0.7764. Our strategy for between is now that we have both of those, now we need to subtract them. And the cool thing is you always get to do bigger minus smaller. So 0.7764 minus 0.0274. 0.7764 minus 0.0274. That gives me 0.749 as my answer. Then the last thing we could ask in this chapter is we could give you that percent, that proportion, and ask you to find the z-score. All right, so this is where we need to find that inside the table. Now, you won't be able to find it exactly. The goal is to find the closest thing that we can to it. So 0.15. Okay, so 0.15, the closest we're getting is it's going to be in between here, right? That's where the 0.15 is going to be. Now, I always go to what it is closest to. So technically, this one is going to be closer to it. So once I have that, I drag this back to find the z-score is negative 1.04. So that's what we mean by working backwards in these, is you find it inside the table, and then the edge of the table will tell you the z-score. So that is what I need you to remember from chapter 6. Moving on to 7, okay? So you notice there's a lot in chapter 5, but one of the questions is honestly just going to be, what type of graph is this? So I'm hoping that you can tell me that this graph is a scatter plot. Again, so many points on your final are just, can you name the type of graph? Okay? Now, also predicting the weight of a 10-year-old. All right, so here, if I were to draw a line here through all this data, okay, that would probably be a good measurement for my line of best fit, something like that. If I want to make a prediction about a 10-year-old, well, I'm saying what? Probably between 13 or 14. Right? One of those would be a good estimate. On the actual final, when it's multiple choice, it'll be obvious which one it is. Okay, it won't give you in between two very close options. But again, when you're making a prediction, all you have to do is just look at the scatter plot and then tell me, oh, okay, it looks like it should be about there. When it comes to explanatory versus response, so remember, explanatory we use to explain the response. So for this, I think it makes a lot of sense. We would be using age to explain their weight. Now, not only does that make sense, but also visually, we do always put the explanatory variable along the x-axis and the response variable along the y-axis. So the fact that you had your graph actually also very much indicates which is which, okay? But again, at its core, you are using the explanatory to explain the response. Here, using age to explain weight. Alright, so correlation. So correlation, we use R to represent correlation. And remember, it measures the strength of their relationship. Or back in the chapter, you heard us use the term, it is a measure of association. Alright? Correlation can be between negative 1 up to positive 1. Okay, those are the different numbers it can be. The closer it gets to -1 or +1, the stronger the relationship is. The closer it is to 0, the weaker the relationship is. Okay, so make sure you remember that. Also, we'll practice that a little bit down below. Strong relationships look close together like a straight line. Okay, the looser your dots are, the weaker the scatter plot is. The tighter, more compact that they are, the stronger your relationship is. All right, so given that, for each of these, let's just really quickly label the strength that we see in in all of these. Okay, so this one, I would say, is moderately strong. Okay, it's not perfect, but it's definitely a pretty well put together line. Now this one is definitely negative, this next one, and I say is actually stronger. So I say this one is a strong negative relationship. Oh, I'm sorry, not moderately strong. I meant to say moderately positive. I apologize. This one I'd say is a much more moderate negative relationship. It's not as well put together, but you're still definitely seeing it's forming a line. This one, wow, is this weak, okay? So this one is weak versus I'd almost say no correlation. Again, you can barely decide if it's positive or negative. That is a very, very weak relationship / basically no relationship. This one is a very strong positive relationship. All right. So let's really quickly also discuss the interpretations of these things. So 2 other things that can pop up is, what does slope actually mean? What does y actually mean? Well, slope is saying when x goes up by 1, it is telling you how y is predicted to change. Okay? And the y-intercept is saying when x is 0, y is predicted to be whatever that y-intercept is. Okay? So here we have some data, okay, for sales and advertising dollars. They give us a scatter plot. And then here they actually give us the equation. All right? And so what they want us to do is, first of all, what is the slope? Then interpret the slope. Same thing with the y-intercept. Well, slope, remember, slope is always the thing with your variable. So here your slope is going to be 13.9. And again, what we're saying is, as x goes up by 1, it's saying that y is predicted to go up by 13.9. Of course, I don't actually want to phrase it that way, though, because here x is representing advertising dollars, y is representing sales. So instead of saying when x goes up by 1, I'm going to say when advertising dollars go up. But in this case, instead of 1, actually, that's going to represent 1,000. And then sales are predicted to go up by 13.9. So for each additional $1,000 in advertising, sales is expected to increase by 13.9, or AKA $13,900. And then y-intercept. The y-intercept is the other value, the 28.65. And again, what that is saying is when x is 0, it's saying y is predicted to be that 28.65. Okay? So, with that, now we can interpret that. Again, we don't want to use x and y, we want to use the advertising dollars and the sales in our explanation, in our interpretation. And then finally, which is explanatory, which is response. Well, remember we said explanatory is always going to be along the x. So this is going to be the explanatory variable. Response is always along the y. So the response is sales. We are using the advertising dollars to explain the sales. All right, so that is it for chapter 4. Now, chapter 7. Now let's wrap up with chapter 4. All right, so chapter 4, collecting data. So this was our very brief chapter, just on how we collect data, okay? So variables are the questions you ask for each individual in your sample, okay? So you find your sample of people, okay? The variable is basically just the questions that you're asking, the data you're collecting. Quantitative variables are numbers that measure something for each individual. So quantitative, you've also probably heard of sometimes called them numerical variables. They are numbers, except there are a couple circumstances. So, for example, things like zip codes, things like phone numbers. If you can't do math with the numbers, if the average and nothing like that makes sense for the numbers, then they actually don't count as quantitative. Quantitative, you have to be able to average them. So like height, weight, stuff like that. If they're not numbers, or if you can't do math with the numbers, then they're called categorical variables. And those put individuals into a group that can be classified under. And like I said, occasionally can be numbers such as area code, zip code, all of that jazz. So, with that said, let's go through and identify how many variables were measured and classify each one. So here, when we're talking about name, so this I don't count as a variable. That is identifying my individuals, okay? Those people are my individuals. Then the rest of these are my variables, okay? So the first one, sex, male or female. Well, that would be categorical, right? Any word response is automatically categorical in nature. Homeroom, that would also be categorical, okay? Those are word responses. Grade level, that would be categorical. Again, freshman, sophomore, junior, senior. Calculator number, now here's one, they are numbers, but it doesn't make sense. Do you want to average your calculator numbers of your class? No, that makes no sense. So technically these would be categorical as well. The only one that's quantitative is test scores, because it doesn't make sense. You can find the average test score, okay? That is math that you would do. That makes sense to do. So here we would say there are 5 variables total. 4 are categorical, 1 is quantitative, okay? So that's how that one would go. Now, another important distinction is talking about experiments versus observational studies. So an experiment, the key is you impose a treatment on your subjects. You are doing something to your subjects. You're giving them different medications, something like that. But again, you are actually imposing a treatment on them. Observational studies, that's not the case. Observational study, you're merely observing. You're merely doing a survey, something like that. You're not trying to affect the results of anything. You're just, again, an observer. In a census, that's where the entire population is surveyed, okay? And again, those are usually difficult to manage because it's hard to contact the entire population. We talked about back in the chapter, that's why we only do the US Census once every 10 years. So our example above, is this an observational study or an experiment? Well, I'd say that this is an observational study, okay? Again, we weren't imposing a treatment, we were just collecting information from these people, from these individuals, okay? And so this would be an observational study. And that is all for our chapters 7, 6, and 4 review. Thank you so much for watching. Hopefully this helped. Please make sure that if you have any questions, please make sure you ask your teacher before the final to make sure we can get you all sorted out before it.